Good day all. Welcome to Sir Joe Science Class TV. At this moment, we'll be focusing on Neco 2026 chemistry theory, basically on organic calculations. Before we move to the calculations proper, there are some areas in which the definitions are to be given, starting with organic chemistry. Organic chemistry is the branch of chemistry that studies carbon compounds and their reactions, excluding their oxides, carbonates, and cyanides. Now we move to the formula of organic compounds. What are the formula of organic compounds? There are three different formula of organic compounds. Namely, one is empirical formula. The second one is molecular formula. And the third formula is structural formula. Now, what is empirical formula? Empirical formula can be defined as the simplest whole number ratio of atoms in or of a chemical compound. That is, empirical formula is the simplest whole number ratio of atoms of a chemical compound. Now we move to molecular formula. Now, for molecular formula, this is the actual number of atoms in a molecule of a chemical compound. E.g., the actual number of glucose is C6H12O6. The actual number of glucose is C6H12O6. While for the empirical formula, the whole number of atoms of glucose is CH2O. Now we move to the structural formula. Structural formula. Structural formula. This is the formula that shows. This is the formula that shows how the atoms are arranged. And bonded. Now, having given the three different formulae of organic compounds, we move to the calculations. Now, I'm taking this question from the first theory question. And the question says, a hydrocarbon with a vapor density of 29 contains 76% carbon and 17.24% hydrogen. Then determine the number one empirical formula. Number two molecular formula. And number three structural formula of the hydrocarbon. Given that the atomic mass of hydrogen is equal to 1.00, atomic mass of carbon is equal to 12.00. Look at the question very well. A hydrocarbon with a vapor density of 29 contains 82.76% carbon and 17.24% hydrogen. Determine the number one empirical formula, molecular formula, and the number two, then number three structural formula of the hydrocarbon. Then the atomic mass of hydrogen is 1.00, atomic mass of carbon is 12.00. Now, as regards this question. I need to explain what is meant by hydrocarbon. A hydrocarbon is an organic compound that contains carbon and hydrogen only. Carbon and hydrogen only. Now I move to the solution. Now for the solution, we must go one, which is on empirical formula. Now, what are the component elements here? The component elements are carbon and hydrogen. Carbon and hydrogen. So, percentage by mass, that's percentage composition. We state percentage composition of each element. Now, for the percentage composition of each element, we have for carbon is 82.76%, 82.76, while for hydrogen is 17.24%. 17.24%. Now, the next step to solve this question is by dividing by the atomic mass of both carbon and hydrogen. Divide by atomic masses. Divide by atomic masses. Now, the atomic mass, so which means that this 82 for carbon is 82.76 divided by 12.00, while for hydrogen is 17.24 divided by, we have 17.24 divided by 1.00. Look at it here. Divide by atomic masses, that is 82.76 divided by 12.00. That's for carbon. And for hydrogen is 17.24 divided by 1.00. Now we now use our calculator. 82.76 divided by 12.00 is equals to 6.897. Here we have 6.89, 6.8967, and here we have 17.24. Then the next step is to divide by the smaller value. Divide by the smaller value. We are dividing by smaller value because we are comparing between carbon and hydrogen. In a situation whereby we have more than two elements, it will be divided by the smallest value. So here we have 17.24 divided by 6.8967. That's for carbon. Then for hydrogen is here we have 6.8967 divided by 6.8967. Then here for hydrogen we have 17.24 divided by 6.8967. Here we have 6.8967 divided by 6.8967. Then for hydrogen, we have 17.24 divided by 6.8967. So here we have for carbon, this is 1. Then dividing 17.24 divided by 6.8967, we now have 2.5. So which means that because this is in form of decimal, this is in decimal places, we now take it to whole number. So we multiply 1 to take these values to whole number. We multiply 1 by 2, then 2.5 as well by 2. So we now have 2. Because 1 times 2, that is 2. Then 2.5 times 2, here we have 5. So which means that empirical formula here, the empirical formula is C2H5. C2H5. That is the empirical formula. Now, having calculated the empirical formula, we move to the second question, which is on molecular formula. So now we have Roman figure 2. For Roman figure 2, we have that is molecular formula. In order to calculate the molecular formula, we make use of the vapor density, and we make use of the vapor density and the empirical formula. So which means that we are to equate C2H5N equals to 29 times 2, or VD, we say VD times 2. That is vapor. VD means vapor density. Now we cannot use the value for vapor density directly. We have to convert vapor density to molecular mass. So that is why we have VD multiplied by 2, because vapor density times 2 is equals to molecular mass. So in this case, we now have C2H5 into N is equals to, now our VD based on the question is 29. Then 29 times 2. So we have 29 times 2. So we now have C2. Our C is 12 because carbon is 12. The atomic mass of carbon is 12. So we have 12 times 2 plus 1 times 5 into n. Everything is equals to 58. So 12 times 2. 12 times 2 is equals to 24. So in this case we have 24 plus 5 into n equals to 58. So which means that by the time we add 24 and 5, we have this implies that 29n is equals to 58. Then from this 29n equals to 58, we divide both sides by 29. So we have 29 divided by n. 29n divided by 29 is equals to 58 divided by 29. Why are we dividing by 29? We are dividing by 29 because the coefficient of 29n is 29. So 29 goes here 1, 29 goes here 1. So we now then 29 into 29 1. 29 into 58, that's 2. So our n is equals to 2. Now, because our n is equals to 2, we have to substitute 2 back to this formula. So we now have substitute 2 for n in C2 H5 in C2 H5n. So we now have, this implies that C2 H5 times 2, which is equals to C4 H10. Therefore, our molecular formula is C4H10. C4H10. It is possible for the question to go further and ask you what is the name of this organic compound. The name of this organic compound is butane. So that is butane. Now move to Roman figure 3, which is the structural formula. Roman figure 3 is the structural formula of this compound, which is structural formula of butane and C4H10 is equals to C So the empirical formula, the structural formula is this one carbon atom bonded with another carbon atom bonded with another carbon atom. So we have 4 carbon atoms. 1, 2, 3. We have 4 carbon atoms now. 1, 2, 3, 4. So then we have hydrogen atom, 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 and hydrogen atom. Now, so we have C4, 1, 2, 3, 4 for carbon atoms. Then for hydrogen atoms, that's 10 hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is butane, and this is the structural formula of butane. Now, with this, I believe you've understood every aspect that I have taught you. Take note, we have three different formulae of chemical compounds, which are the empirical formula, molecular formula, and the structural formula. So that's it. That's up for today. During the next lesson, we are going to take some other aspects of chemistry. Always tune in to Sir Joe Science Class TV, and do well to like, comment, subscribe, and share to Sir Joe Science Class TV. God bless you all.